Math 1143, Test 3 Review Sheet, Chapter 3 Material, Section 3.2 on exponential functions. In number 1, graph each function, find all intercepts, then find the inverse functions. Well, this is an exponential function. We can plot a few points. We have a formula for finding y-coordinates whenever we pick an x-coordinate. So if we pick x to be, say, 0, e to the 0 is 1, 1 minus 2 is negative 1. And then if we pick x to be 1, e to the first is 2.718 approximately, so 2.718 minus 2 is about 0.718. So we'll plot those points and then see what else. Oh, this e to the x minus 2, that indicates that the horizontal asymptote is the line y equals negative 2. Y equals negative 2. The y-intercept is 0, negative 1. And so the x-intercept is somewhere between 0 and 1, because the ordered pair 1, 0 sevenths is 0.718 is about right here. So this graph looks something like this. But how do we find the x-intercept? Well, we replace y with 0, or f of x, replace that with 0, set it equal to e to the x minus 2, and then this is e to the x minus 2, and then solve this for x. So add 2 to both sides, we get 2 equals e to the x, and then take the natural log of both sides, we get the natural log of 2 equals the natural log of e to the x, which is just x, and the natural log of 2 is about 0.693, so that's looks like it's in the ballpark. So in other words, when x is the natural log of 2, the y-coordinate is 0. So this is the x-intercept, and 0, negative 1 is the y-intercept. To find the inverse, replace f of x with y, so we get y equals e to the x minus 2. Interchange x and y, so we get x equals e to the y minus 2. And then solve this equation for y. First, add 2 to both sides. That gives us x plus 2 equals e to the y. Then we can take the natural log of both sides. The natural log of x plus 2 equals the natural log of e to the y, but the natural log of e to the y is just y. So that means f inverse is the natural log of x plus 2. Okay, so that's all we're going to do on that one. In part B, we're going to do the same thing, sketch a graph of this function. This is g of x equals 3. The exponent is x plus 3. So the horizontal asymptote is just y equals 0, or the x-axis this time. So we can pick some x values, and this is a formula for finding the corresponding y values. So I'll start with negative 3, and then we'll find some ordered pairs. When x is negative 3, the exponent is 3 to the 0, which is 1. So negative 3, 1 is a point on the graph. When x is negative 2 plus 3 is 1. 3 to the first is 3. And when x is negative 1 plus 3 is 2, and 3 to the second is 9. So we're probably going to be off the grid. And finally, when x is 0, 3 to the third is 27. So let's plot those points. So we know the horizontal asymptote is the x-axis, or y equals 0. So we'll plot a few of these. Negative 3, 1 is a point on the graph. Negative 2, 3. Negative 1, 9. So negative 1, 9 is right here. So the graph looks something like this. Okay, then to find the inverse, replace g of x with y, so we get y equals 3 to the x plus 3. Then interchange x and y, x equals 3 to the y plus 3, and then solve this for y. So we can use any logarithm we want. We can use the natural log, take the natural log of the left-hand side and the natural log of the right-hand side, 3 to the y plus 3. And then the exponent is y plus 3, so we can write this as the natural log of x equals y plus 3 times the natural log of 3. Then divide both sides by the natural log of 3, so we get the natural log of x divided by the natural log of 3 equals y plus 3. And then the last step is to subtract 3 from both sides. So I'll just write what G inverse is after we subtract 3 from both sides. G inverse is the natural log of x divided by the natural log of 3 minus 3. Okay, the next one, sketch the graph of v of x equals 2 to the x minus 2 plus 1. This plus 1 over here indicates that the horizontal asymptote will be the line y equals 1. But let's find a few x coordinates, x and y coordinates. So if we pick, say, x to be 0, then we get 2 to the negative 2, which is 1 over 2 to the positive 2, or 1/4, and 1/4 plus 1 is 5/4. And then if we pick x to be 1, 2 to the 1 minus 2 is 2 to the negative 1, which is 1 over 2, or 1/2. 1/2 plus 1 is 3/2. And then if we pick x to be 2, we get 2 to the 0, which is 1. 1 plus 1 is 2. And one more ordered pair ought to be enough. When x is 3, the exponent, 3 minus 2 is 1. 2 to the first is 2. 2 plus 1 is 3. And then the horizontal asymptote is y equals 1. So make sure you get that in there, y equals 1. And 0, 5/4. 1, 3/2. 2, 2. And 3, 3. So this is the graph, roughly. Okay, to find the inverse, replace v of x with y. So v of x equals 2 to the x minus 2 plus 1. Interchange x and y, so we get x equals 2 to the y minus 2 plus 1. And now we want to solve this equation for y. So first subtract 1 from both sides. X minus 1 equals 2 to the y minus 2. This time I'll just convert this exponential equation into a base 2 logarithmic equation. So since the base of the exponential is 2, then I'll use a base 2 logarithm, and the exponent, y minus 2, is equal to the base 2 logarithm of x minus 1. And then we just add 2 to both sides, and that will be the inverse of v. V inverse is log base 2 of x minus 1 plus 2. You can also write v inverse using the natural log. You can use the change of base formula if you want. So if you do that, then v inverse is the natural log of the argument x minus 1 divided by the natural log of the base, which is 2. So the natural log of x minus 1 divided by the natural log of 2 and then plus 2. That's the inverse. Okay, next page. The amount of $800 is used to purchase a CD, certificate of deposit, that earns interest at the annual rate of 4% compounded monthly. The CD matures after 54 months. Find the value of the CD at maturity. So the compound interest formula, the initial amount is $800. And so A equals 800 times 1 plus the decimal form of the interest rate, 0.04. And the interest is compounded monthly. That means 12 times a year. And then the function has an exponent of 12 times t, where t is the number of years. Well, if the CD matures after 54 months, 54 months is 4.5 years. So if you replace t with 4.5 and multiply it by 12, then you just get the number of months. Okay, so the value of the investment after 54 months is just A equals 800 times 1 plus 0.04 divided by 12 raised to the exponent 54. And then you can use a high-powered calculator. If you're not going to use a calculator, then this is the answer. But you can use a calculator if you want to get something to relate to. Okay, in the next problem, find the annual interest rate necessary for a deposit of $5,000 to grow to $8,000 in 10 years if interest is compounded continuously. So let's write down the function. The amount invested initially is $5,000, and the interest is compounded continuously, so it's e to the RT. So this is the function, and then we're told that we need to find the interest rate R if after 10 years the value of the investment is $8,000. Okay, so what we're going to do, we're going to replace A with 8,000, replace T with 10, and then we'll solve the equation for the interest rate R. Okay, so A is 8,000. We set that equal to 5,000 times e to the 10R. Then divide both sides by 5,000. 8,000 divided by 5,000 is 1.6. So 1.6 equals e to the 10R. And then we can take the natural log of both sides. The natural log of 1.6 equals the natural log of e to the 10R. But the natural log of e to the 10R is just 10R. And then if you divide both sides by 10, the annual interest rate is R equals the natural log of 1.6 divided by 10. And you can use a high-powered calculator and convert this to a decimal number. And then the percentage is what you get if you move the decimal 2 places to the right and put a percent symbol after the decimal number.